So, good afternoon, everyone. I'm Jintian from TU Eindhoven, and I'm a PhD candidate. So, today I bring this topic, decision support framework for integrating construction consolidation centers into sustainable waste management. So, it's a project level case study. Here comes the context. So, we focus on inner city projects during the finishing stage. So at this stage, waste volumes are smaller, but the waste streams are more diverse. So including timber, drywall, plastics, metal, and packaging things. So and the limited space because it's in the city, limited place and space make this waste stream difficult to manage. And yeah. Inner city sites often have very little storage space, as I said, so there may not be enough room for separate containers. So different waste streams are collected together. So this means it's very hard to sort it when we later try to recycling these kind of things. And yeah. I need to have some definition for this. So, Construction Consolidation Centre, or CCC, is an off-site logistic hub. So it's normally used to combine material delivers before they are sent to construction sites. So in this study, we extend this role. We try to extend this role to waste collection. So small containers can support source separation, and the waste can be collected during the return trips. So when the car from the construction consolidation center to the construction site, it can bring all the waste back. And here comes the research questions. So how can a construction consolidation center be integrated into outbound construction and demolition waste management during the finished stage of inner city construction project? I can just go to the method part. So here's our framework. So we compare two waste strategies using the same project data. So the inputs data include project size, waste amount, travel distance, and the storage capacity. We then compare total cost, carbon emission, and the vehicle trips. And for these two scenarios, both scenarios including material delivers from the CCC to the construction site. In the baseline, the vehicle returns without collecting waste, and the mixed waste is removed later by a separated trip to the recycling facility. And in the CCC-enabled scenario, the return tray is used to collect source-separated waste and bring it back to the CCC. Yeah. So the model used three groups of data. Project data used to estimate weekly waste generation, logistic data using a weekly simulation to calculate the vehicle loading, container use and the return trip. Performance factors are then applied to calculate the total cost of carbon emission and the vehicle trips. Here's our three cases. So including former mutation venue in Utrecht, and also a new construction of a resident high-rise building, and yeah, first one is a hotel renovation in Amsterdam. Yeah, here comes the result part. So based on these two scenarios, we can see like the total cost decrease in all three cases. So by around 20% to 37%. So the largest reduction is in the middle one because the transport and the container cost increase, but this is outweighed by lower mixed waste processing cost. Yeah. And for the carbon emission, in all three cases, this all decrease. Also, the first one flows from 22.4 to 2.7, and also the middle one is falling the most. So this reduction comes from avoiding mixed waste sorting, because this process really generate very much of carbon. And the main trade-off, we can see here's the number of vehicle trips. So trips increase by around 8 to 15% because separate waste streams require more container movements. So we use this as a simple indicator of traffic noise and safety impacts. Okay, so here comes the discussion. The result comes from three main effects. So lower mixed waste processing costs reduce total cost. Avoiding mixed waste sorting reduce the carbon emission. But separate waste stream need more container movement, so vehicle trips increase. Yeah. And here comes the conclusion part. So the framework helps project teams to compare to waste strategies before the logistics plan is fixed. So in those three cases, the CCC-enabled scenario reduce module costs and carbon emission, but increase vehicle trips. So it's therefore not always the best solution, but its value depends on the project conditions. Also, we have sensitive to several conditions. The baseline become economically competitive only if mixed waste processing costs fall by around 24 to 31%. So it makes more profits and more convey for this for choice. And then the study is based on three, and also for the limitation part, because we study only three Dutch cases, and it's also cover only transport and mixed waste sorting, emission, not a full life cycle assessment, and also it's more focused on an early stage model instead of the whole process. Yeah, so thank you for your attention, and happy to take your questions.